So I'm starting live now. Live.
Good morning, ladies and gentlemen. You are welcome to today's e-technical meeting brought to you by the Society of Petroleum Engineers, Lagos section. In line with our mission, we seek to collect, disseminate, and exchange technical knowledge within the oil and gas industry. And for that purpose, we have brought together this presentation proudly sponsored by Owando Energy Resources. My name is Fayama Okoli, the program's chair of Lagos SPE section, and the title today will be talking about small unmanned aerial systems and their application in oil and gas asset surveillance, inspection, and security. Our presenter today is Mr. Anthony Sawyerr. I will go through his profile, and after that, we will hand over the platform. Engineer Anthony Sawyerr is the General Manager Operations for Owando Energy Resources, with the overall responsibility for production, drilling, and well operations, as well as facilities engineering and capital projects. He is also the Owando technical lead for NAOC Owando joint venture. Mr. Anthony has 28 years of experience in the upstream oil and gas operations, beginning with a 15-year career in ExxonMobil. He has performed engineering, operations, and management roles in drilling, covering onshore, offshore, and deep water, production, planning, field development, and terminal operations and projects. Engineer Anthony is a fellow of the Nigerian Society of Engineers, a current registered engineer, a member of the Society of Petroleum Engineers, a member of the American Society of Mechanical Engineers, and the American Association of Drilling Engineers. At this point, I would like to hand over the platform to Engineer Anthony Sawyerr as he takes us through this very interesting topic. Over to you, sir, please.
Thank you very much. Thank you very much. Good afternoon, good morning, ladies and gentlemen. I'd like to appreciate the Society of Petroleum Engineers for giving me the opportunity to talk about this novel topic. The topic, again, as introduced, is small unmanned aerial systems and their application in oil and gas surveillance, inspection, and security. So what's going to happen is I'm going to go and talk about the challenges that we have in the oil and gas industry, which would need, we'll be able to use UAVs, the hardware, different types of the benefits and selection considerations. I also talk about the applications in oil and gas operations, concepts of operations, do a quick conclusion, and I'll take questions afterwards. Okay, so the challenge, the need and the complexity. So successful operations in the oil and gas industry depend on asset security, strong health, safety, and environment culture, asset integrity, and technical compliance and assurance. One of the challenges we have is the terrain. If you take a look at the picture on the right, you will see a complex maze of, well, what I could term spaghetti. Each of those little points is actually a pipeline. And unfortunately, or well, fortunately, unfortunately, oil is not always in the nicest of places, is it? So you have pipelines in the swamp, on land, offshore, in the bush, in serious jungle, as well as urban areas. So, and a lot of these pipelines sometimes are interconnected and dependent, and connecting a wide variety of assets. So to be able to deal with watching a lot of these things and making sure they're in very good shape, you have a lot of challenges. Again, your challenges will be a lot worse or a lot more difficult in the swamp as opposed to land, for instance. And of course, if you look at things like offshore, you'd have less complexities than you would probably in the swamp and on land. But again, the more complex the operations are, the more equipment you need, the more support and logistics, that's obviously required, as well as the opportunities for disruption. Again, the chances of disruption of your pipeline network is a lot more prevalent probably on land and in the swamp than you'd say offshore or deep water, for instance. But all these complexities that you have come with costs. Again, cost. That's very, very sinister word. So right now, what do we have in terms of our methods of surveillance? Our typical methods of surveillance that we have right now are your manned aerial surveillance. Again, this is taking your helicopters across your pipelines, just taking a look at how things are going on a regular basis. You also have community surveillance, where you have community personnel who take a look at our assets. And then you also have patrols and inspections. These are probably typically done by the company itself, the operating company. And then you have electronic surveillance. The problems you have with each of these I'll just stress in a minute. For manned aerial surveillance, the challenges you have, well, again, what we're talking about here is helicopters. So you'd go in a helicopter, you'd go across your pipeline, your assets. A guy would be on the door or at the door with a pair of binoculars and he'd be looking down, right? The problem with that is there's risk to onboard personnel. Again, every time you take a helicopter up, obviously there's a risk there. In addition to that, if you are flying over terrain which is not very friendly, there have been incidents where people have shot at helicopters, obviously they don't want themselves to be watched. You have insufficient frequency. Again, you can only go over your assets so often, and inadequate data capturing. So apart from a few photographs you could take, there's really not much you can do as far as that's concerned. In the community surveillance part, you have untrained personnel. Again, these are your community guys that essentially you will pay to take a look at your assets. Limited oversight, limited control, and the biggest part of it, limited accountability. There's really no need for them to take care of your stuff, is there? For field patrols and inspections, what you have is, again, the company with your security personnel going around, taking a look at the assets. The challenges you have are terrain difficulties, putting your people in harm's way. That's a bit of a challenge too. And of course, the high operating costs associated with it. Electronic surveillance, now that's a pretty high capex item right there. One of the biggest problems you have in remote areas, especially in our own societies, is that the installed equipment can be stolen or vandalized on the regular. So you would put a nice big mast with a camera and solar panels, obviously a power source to be able to monitor an area, and I'm confident that before nightfall, the new owners would have carried the solar panels, carried the cameras away, again, giving you the challenges that we face. Again, all of these things add up to a very, very high cost on a yearly basis. So what is the goal? The goal, first and foremost, is safe operations. To be able to execute your surveillance and monitoring and inspection activities in with safety of personnel, equipment, and assets in mind. Cost effective, of course, we're not going to continue to, we don't want to pay excessive amounts if we don't have to. Minimum amount of downtime, and an integrated approach. An integrated approach where we could take data from several sources and essentially put it together and give us a big picture of what exactly is going on. We want improved control of human error, of course, to be able to have correct use of algorithms, analytics, and evaluation of data, which will give us increased accuracy. And last but not least, we want a quick and efficient response. Again, it does not make sense if you have information which is several hours or several days old. You lose the initiative and it's essentially useless. Options. We looked at several options with a large, across the entire spectrum of surveillance, starting with satellite imagery. Satellite imagery is, of course, as the name implies, the use of satellites to give us images of the Earth. Now, your Google map is a good example of such satellite imagery. The challenge you have with that is that it's pretty expensive and it's infrequent. Your satellite takes a typical time of about 24 hours to go back to a particular position if you have any image of interest. Again, in 24 hours, a lot of things could change. So that is not exactly a very useful means of surveillance. Sentry Towers, again, like I explained previously, they're very conspicuous, they're very easy to vandalize, and they're very difficult to deploy. You can imagine putting a few of these Sentry Towers in the swamp or in other inhospitable terrain. Again, some of these Sentry Towers are used for surveillance in other areas where there's a little bit more control over the asset itself. You have tethered aerostats, essentially is your balloons. These are tethered over heights of about 2,000 plus feet with high resolution cameras. The problem with those is that they are of limited range and they're quite conspicuous. Distributed acoustics, that is becoming increasingly popular. However, the challenge you have with that is that it requires an extensive hardware change. These is essentially putting fiber optic cables, laying them in or around your pipeline. These cables, these sensors deployed can pick up human traffic, can pick up vehicular movements and any type of digging or seismic type activity, which will essentially warn you that your pipeline or your asset is being disrupted. And last but not least is UAVs. Again, there are extensive regulations associated with it, especially in our immediate environment, and it's an emerging technology by all means. But as far as this is concerned, it seemed to be the most promising method of surveillance. So the benefits, what are the benefits of the unmanned aerial vehicle? Again, it's unmanned, which means that if anything happens to it, you've not lost any life, which is, I guess, the primary advantage. The endurance, you have continuous surveillance up to about 20 hours, depending on the model of the aircraft. Operational readiness, it can be ready to go on demand, and it can be pre-programmed to fly a particular path. Portable, some of these UAVs are able to operate without runways or helipads, which makes them very, very portable. Low cost, of course. Lower OPEX and CAPEX, again, your UAV would typically be cheaper than flying a helicopter on a regular basis. By the time you take a look at the costs. Versatile, a lot of these UAVs are able to operate in adverse weather conditions. We know that in our environment, we have quite serious rain and a lot of moisture, and in some other terrains, a bit of dryness. And then, of course, communication, you're able to communicate real time with your base, and a wide array of payloads. Now, this is very, very important. Your UAV is quite versatile to the point whereby if you can carry it, you can use it. So your camera, different types of cameras, different types of payloads, different types of equipment, essentially, to be able to achieve your objectives. I'll go into that in a little bit more detail. But first and foremost, what kinds of UASs do we have? UAS, UAV, unmanned air systems, unmanned air vehicles. I mean, there are different types of acronyms. You can call it, in short, drones, if the acronyms are getting to you. Okay, from the smallest part of the spectrum, your extreme left bottom part, is your Parrot. Parrot is like your normal DJI Phantom, your basic drones, your quadcopter drones you can buy at any store, which are used for videos or whatever it is. Those are the smallest. Again, I'm just talking about these UASs, the classification based on endurance, altitude, and range, which are the key to selecting what kind of UAS you want. You have the Raven, which is a smaller, which is larger than your Parrot, a bit more endurance, which is in the mini category. In that part, you have ranges of up to about 10 kilometers, and you can go as high as about 150 to 200 meters. Then beyond that, you have a Scan Eagle. Again, coming towards this particular spectrum, you're actually getting close to the terrain of probably military use. So your Scan Eagle would give you, is essentially a low altitude, long endurance type vehicle. You can do in excess of about 250 to 300, in fact, some cases 500 kilometers range. And your altitude can be as much as about 5,000, between 5 to 7,000 meters altitude. Everything to the right of that is strictly military. I mean, a lot of us have heard of Predators that are used for not very friendly things, especially, and also the Global Hawk and your Strato, and those essentially are military. So it's quite unlikely you'll be able to buy them for oil and gas use. And then your payloads and sensors. Now, these are the things that your UAVs will be carrying. Optical cameras. Again, if you recall, I mentioned that in the case of a helicopter and our normal use right now, you have your guy sitting down at the door of the helicopter, looking downwards with his camera, taking a few pictures here and there and a binocular to look around. But you have optical cameras, which are more versatile with zoom capability and other very advanced sensors that you can utilize on your drones. Thermal cameras, these are able to detect differences in temperature, which make them very versatile through night, and also are able to see through fog and smoke, and are able to detect intruders through tree cover. Again, in the Delta, you have a lot of foliage, so obviously you want to be able to see through that foliage. You have hyperspectral cameras, and you have shortwave infrared cameras which are able to detect spills and through moisture detection. You have LiDAR, which is 3D sensing, shortwave infrared cameras, and communications antennas, which can boost communication signals and range over a larger area. So you can see these are very, very versatile options that can be carried by your UAV. So the selection factors for oil and gas operations, I mean, how would we select the appropriate vehicle from all the several options that are available? First, you want to take a look at your application. What exactly are you trying to do? Do you need long range, short range, etc., things of that particular nature, localized use or distributed use? Portability, lightweight, which is quite important. The ability to launch and recover very quickly, and the use of minimal manpower to be able to run such operations. Of course, of importance is your range. How far do you want to go? What is the limit of the assets that you want to take a look at? And then how far they are from the control center, etc., etc. Altitude, you want to be high enough to be stealthy, of course, so that people will not be able to shoot at it. And then you want to be low enough to have very good quality imagery. Endurance, you want your UAVs to have a substantial amount of time on target. And of course, the availability. Are they readily available? Are they readily available? And, of course, your costs. And then again, the payloads that you want to carry. So on my right, you see the different types in the mini. So again, for oil and gas operations, you'll be looking at the first four: your mini, your short range, your medium range, and your medium range endurance, essentially. You have your minis, again, your normal drones, your short range, things like your Anduril Ghost 4, medium range, like the Lockheed Martin Stalker, and medium endurance, like your Flex Rotor. So what kind of applications we will be using these vehicles for? First things first is your asset monitoring, surveillance, and mapping. Essentially just an eye in the sky, okay? So the things that you normally send your guy or your personnel out into the field to take a look at, you'd send your drone. Right-of-way surveys, site layouts, site and layout surveys, well pad monitoring, and general surveillance. In this particular regard, you'll be able to have your drones, which have cameras, zoom cameras, to be able to take a look at gauges on your wellhead. If your wellheads are in remote locations or your facilities are unmanned in remote locations. Again, it removes the need to send your personnel out there, especially if you have safety concerns or terrain concerns. For asset security, protection, and incident monitoring, as the name implies, security, you want to be sure that your facilities are secure, and you want to be able to monitor them on a regular basis. Your drones are able to detect threats along or around your facilities, verify incidents in the events in situations where incidents have occurred, and also assist in crisis management from anywhere. And of course, when you have incidents, you typically would have a joint investigation team, and these aircraft can provide investigation team support, especially when access especially when access is limited. Again, you want to be able to detect, to notify, and to be able to monitor. Another use is surface equipment inspections. This is becoming increasingly popular. You have flare stack inspections, which are typically now carried out by drones, offshore platform inspections, pipeline visual inspections, and pipeline thermal inspection. This is actually very, very interesting because you can use thermal sensors to be able to take a glance at your pipelines and are able to be sure that things are working in normal required ranges that they are. You're also able to look at tanks, and vessels, especially those with very serious height and depth. Very important is environmental monitoring and impact assessment. Combining different images together, you'll be able to take a look at the environment impact assessment, emissions monitoring. UAVs can be equipped with different type of gas emission sensors, and you're able to take a look at your vegetation over a period, the impacts of an oil spill, for instance, what it was, how it's from a historical perspective over a few days, how the oil spill has moved, or if there's any remediation in your environment as a result of that oil spill. Other applications which are also gaining a lot of popularity are construction progress monitoring, where you're able to see on a holistic basis how your construction site looks after the progress that you expect to be going through. Your pipeline route evaluation, taking a look at erosion levels and elevation evaluation, as well as 3D scans of facilities. 3D scans of facilities, I mean, those are very, 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 very important nowadays and are used for a variety of projects, and they're becoming increasingly popular. The guy on the right is prepping a quad, or this is actually 6 props type vehicle for construction type inspection. In addition, you also have UAVs for marine applications, unmanned aquatic vehicles. They also exist. These go underwater to inspect subsea facilities, subsea pipelines, umbilicals, and stuff of that nature. And you also have surface types of marine applications where you could essentially have your remotely piloted drone going through your sea lanes or going through your swamp lanes, essentially patrols that normal manned patrols would typically be doing. So this can be done on a remote basis with vehicles as opposed to just your traditional ways of doing it. So we're also going to talk now about the additional value-added propositions that you have, the software, the analytics, and the things that make your UAVs a lot more quote-unquote intelligent than your normal eye just taking a look at and inspecting different things. So they have several benefits of analytics and Internet of Things integration. First is your internal map generation, where you see several individual snapshots, pictures which are stitched together to create a seamless map. One of the advantages of this is that you can take a look at time changes or how a particular area has been, if there's any disruptions, you can see over a particular period, because your map over a particular period might change if there are disruptions. You also have automated spill detection. Now your different levels of spectral images are able to detect different types of spills, and in many cases also able to estimate your volumes of the spills. Very, very useful for environmental monitoring. You're also able to have increased machine learning such that signatures such as smoke can be detected. Artificial intelligence has gotten to the point now, and machine learning, where you can essentially teach these UASs to be able to detect smoke in the case of illegal refineries and things of that nature. I also talked a little bit about environmental impact and change analysis. Again, being able to say, okay, the spill was here, it's now here, changes to vegetation, changes to improvements in vegetation or degradation in vegetation. You're able to see that from a clearer picture by virtue of different types of analytics available. Another point is the response or logistical route generation. By virtue of a larger overhead picture, you're able to create a Google map, for want of a better word. Imagine having a situation in the swamp, for instance, which is typical of that image you can see in number 5, where you're able to plot a route between your assets, the fastest possible way to get to your assets using existing water channels. Typically, you would have been constrained by using people who are familiar with those particular areas, and you may not have the most efficient means of response in situations that require immediate or timely responses. Last but not least is reporting, historical data, automated data, such that we have, timely, concise reports, which we can use to make very, very serious decisions. And of course, you have the transparency by virtue of the fact that it's not subjective, a human being subjective. For instance, a guy taking a look at something may say, oh, maybe it's this, maybe it's not, depending on how tired he is or depending on how blurred his vision is. But your drone doesn't have those limitations. So a typical security and surveillance CONOPS, as it's called in the the game, concept of operations. I'm just going to go through a typical ConOps. So your UAV, typically what happens, it goes along its route, it detects suspicious persons or activities within a pipeline route, right of way, sends real-time imagery to your control and command center. Your control and command center is in constant communication with your vehicle. Direct communication immediately to your nearest houseboats or to your security installation. You now have your security boats dispatched to intercept and investigate the alleged intrusion. All this time, your UAV is circling in the area, able to guide the teams to the exact location of the interference, and also be able to, update the information as it becomes available. Then, of course, the surveillance will now continue until the threat is detected and eliminated. So, in conclusion, the future of asset monitoring and surveillance. Coming from where we're coming from, we see a world or an operation where we can create a vast network of UAS infrastructure to replace conventional manned helicopter and individual efforts. This can be integrated into existing infrastructure, that's the Internet of Things, where you have each of the equipment and each of the surveillance systems talking to each other. It also provides vast data for improved analytics. Again, the more data you have, the more you'll be able to do very, very useful analytics, which can help in making decisions. And ultimately, the reason for this is to be able to reduce the operational complexity and improve uptime. So how do we make this possible? The requirements for commercial drone applications in Nigeria require several steps. There's suppose that you need to conduct research and development of operations within the Nigerian oil and gas space. Security clearances are required from different security and intelligence agencies in Nigeria and from technical partner countries, obviously, before, depending on the suppliers, these things are required, ITA permits and things of the like. Permits and certificates for end user licenses from the aviation regulatory bodies. A proof of concept, of course, test flights and demonstration of analytics, and then solid and robust technical partnerships for both hardware and analytics. There are a few service providers. Proviant Integrated Services provides a very, very robust solution to these type of challenges. And they are pretty well set up to provide these services. So as an industry, what are the next steps? We have to be able to promote the adoption of UASs in oil and gas operations. From the examples I gave, it's clear that we can do things in a more efficient fashion if we adopt this technology. We have to be able to work with the regulatory bodies to develop operational guidelines with strong emphasis on safety. Very, very critical. Again, you're going to be working in a space where helicopters are bound and where other civilian air traffic is abound. So there has to be proper emphasis on safety. We must be able to continue to integrate UAS functionality into existing operations to have a holistic support systems. Again, one of the big problems is a communications framework, especially in remote operations. Has to be essentially has to be upgraded to be able to meet the challenges of this type of technology. And last but not least, we must be able to initiate training and knowledge transfer programs within the industry. Thank you very much. That is all I have, and I'll be able to take any questions, concerns, comments, and contributions.
Thank you very much. I can hear an echo from my end. Does everybody hear me all right? Okay. Thank you very much, Engineer Anthony Sawyerr, for such an enlightening presentation. It really is an eye-opener to see the capabilities of these small unmanned aerial vehicles. As you have rightly presented, they have very little tiny footprints in our oil and gas space, but they are capable of quite a number of things, not just as a camera to take pictures, but a whole gamut of sensors that enables data flow and data management. This is really enlightening, and I believe it has been so for others on the call as well. We will like to have your questions come in the chat box. Use the chat box to throw in your questions. Engineer Anthony will do justice to every single question that comes in. At this point, I would like to invite Mr. Onyebuchi Okereke to summarize the presentation we have just heard. Onyebuchi Okereke is a past director of SPE Lagos section, and he is a keen participant in this kind of topics. He will give us a brief summary of what we have just heard. Thank you, Buchi. As you take the platform, please.
Good afternoon, everyone. I would like to also appreciate Engineer Sawyerr for such an excellent presentation. As facilitator, if I am just say this was really a holistic, very, very comprehensive overview of this very critical introduction into the operations of the oil and gas industry. We all already know how complex our operating environment is. The fact that we have several challenges that indeed calls for innovation and creativity. So having a talk such as this is really very, very critical to us, or furthering that journey of innovation, that journey of digital acceleration indeed in our industry. So I must appreciate Engineer Sawyerr very, very well. So I won't belabor the fact he was very thorough in his presentation. So all I'll ask is for us to send in our questions to the chat box, as Fayama already mentioned. I'll just go through quick high-level summary, just to help us, all of us, remember the keynotes that he talked about in the course of this presentation, and then Fayama will take the questions that you all would have sent into the chat box. So he first started excellently setting the stage with the various challenges that we have in our environment. The fact that it's a complex operating environment indeed, and one where we are worried about the asset security, one where we're worried about health, safety, and environment, where we're worried about the asset integrity, and as well as also the assurance issues that we have to deal with. The fact that we have a lot of disruptions in the environment, and as well as also the fact that the spread that we have provides huge logistics issues for us. That kind of really set the stage to indeed delve into the goal and the objective of of these small unmanned systems. The fact that it ensures safe operations, it's more cost effective than having yourself with all your huge vehicles driving around the various platforms for you to go and get information that you need, requiring operations in various places. The fact that with this we can ensure minimal downtime because you are very quick, you're very agile in your response, given that you have readily available data, when you need that. The fact that it's also an integrated approach, and also the fact that this helps us reduce human errors that could come with, us trying to execute some of these tasks ourselves. He went ahead to, provide some existing technologies that are already out there in terms of surveillance and monitoring, and then delved into the key benefits indeed of the unmanned aerial vehicles, where he talked about the portability, the versatility, the fact that this has a wide array of data that it can actually capture and trend, and of course, obviously, from the title, that it's really unmanned. So it's a very, very key introduction, as I mentioned earlier on, into our operations, and something that will really, really help us go far. He thought a whole lot about the factors that we need to consider in selecting these various equipment and introducing them into our operations. The applicability of these, the range within our operations, the altitude that it can go, as high as it can go, and how stealth it is in the various places that we want to deploy this, the availability as well, and then of course how cost effective and how durable and reliable these equipments are. He went ahead and discussed also the various applications in the industry in terms of asset monitoring, surveillance and asset security, surface equipment inspections, environmental inspection, which we all know is a very big deal. You know how expensive an environmental mishap could be to an organization. We've heard the different stories in time past and how significant this can be to a business. It can actually cripple a business if not managed very quickly. So this is a very, very key benefit of this equipment, and a whole lot of other applications of this. And talked about even the back end aspect of things, the software, the analytics, the Internet of Things, and all of the integration that comes along with this sort of equipment, and a whole lot of other concepts of the equipment. So I can mention, I wouldn't want to take too much of our time. This was a very comprehensive presentation. I really cannot thank Engineer Sawyerr enough for this. So with that, I would turn it over to Fayama, I guess, for the questions that the audience might have.
Thank you again, Mr. Onyebuchi Okereke. That was aptly summarized, covering all the key aspects. We appreciate your contribution. Indeed, we have a lot of questions for you, Mr. Anthony, about 16 questions right now. We will try to attend to all the questions by giving pointed answers, so we at least give an insight to every single person who has published a question. So I will start from the beginning as they have come in. This is from Mr. Chooks. Thanks for the interesting lecture. What is the best available range obtainable at the moment for aerial and aquatic vehicles? And what mode of communication is adopted between the control center and the UAV, especially when dealing with remoteness? and considering the unreliable and unpredictable communication network in Nigeria?
Okay, thank you very much for that question. There are different types of communications networks available. Typically, you'll be using radio waves because what we're talking about essentially is beyond visual line of sight, right? In some cases, you have, if they're within visual line of sight, then of course it's easier to use your radio waves for that. There's internet through internet connections, but these are Wi-Fi type signals. And then you have some proprietary type signals, depending on the kind of vehicles that you utilize. The range, you could have anything from a few kilometers up to about 400 kilometers, 250, 400 kilometers, something of that nature. Again, it's a function of your endurance, right? So the communications plus your endurance would determine, that level of range. So what you have really is, from a military specification, right, you have a greater range, but obviously you're not in a military specification. So obviously your range will probably be limited to about 250 to about 300 or 400 kilometers maximum.
Okay, thank you very much, Engineer. I will go to the next question, which says, how does the cost profile of adopting these small unmanned vehicles compare with the traditional surveillance systems?
Okay, so if you look at your operating costs of a UAV on an hourly basis, vis-a-vis the cost of running a helicopter on an hourly basis, you're talking about a factor of probably less than about 40%. Sorry, 40% of the helicopter costs, 30 to 40% of the helicopter costs. Plus, you have the added versatility of additional time on station. So, for instance, if you're flying your helicopter, you'll be flying your helicopter and you'll be charged on an hourly basis for that. Fuel, pilots, etc., etc. In using UAV, for instance, you can use multiple UAVs, which obviously you have a lot more versatility than if you had only one helicopter, or you can't send multiple helicopters. That's not exactly very logical. So from a cost profile perspective, we're talking about 30%, 40% of what your helicopters would traditionally charge. But then again, you're not exactly comparing flight hours, right? So you can't exactly say 1 hour of UAV is equivalent to 1 hour of helicopter, because what your UAV can do for that 1 hour is completely different from what your helicopter will be able to do.
Okay, thank you very much. You have compared it to the helicopter surveillance. I think they were also looking at other traditional aspects as community surveillance and some of the other ones you mentioned.
So for community surveillance, I mean, there's a fixed, I mean, you pay the community to be able to do surveillance. Is it effective? There are a lot of questions around that. And I think the overwhelming answer is no. And the things that the community can or will want to see are very, very, very varied. In terms of a cost profile, can you completely eliminate community surveillance? Probably not. But you can enhance it, and you can make it more robust by having an additional eye in the sky.
Correct. Thank you. Thank you very much. All right, we have another question from Anonymous. This person is asking for the slides, saying it's a very interesting presentation. They would like to have the slides after the presentation if possible. What can you say about the opportunities that abound in this area for young engineers or young entrants into the oil and gas sector? The question is, from your experience, is it realistic for one to chart a career path along this area? Most
definitely. Look, the traditional engineer as we know it is gone. Okay, I won't say gone exactly, but going. You have to be more data savvy. You have to be more take things from a more holistic perspective. So your newer entrance into the oil and gas space, there will be more and more opportunities of this nature. I talked about. I'm just going to use very simple examples. For instance, things like 3D equipment scanning, for argument's sake, at heights. These things were typically not available previously, and now they are actually very, very essential. Flare stack inspections, they're easier to do right now. In addition, there are opportunities in flight operations, opportunities as data analysts to be able to properly analyze the data that comes from these aircraft, and then software operators and software developers. So there's a large amount of opportunity, there's a large spectrum of opportunities in this particular space.
Thank you very much. So I would go to the next question. Just give me a minute. We have a number of questions here. What kind of regulatory hurdles did Owando face in being able to deploy these systems in Nigeria, particularly with the Office of the National Security Advisor?
Okay, so it will interest you to know that the first UAV permit that was obtained in Nigeria was obtained by Oando. So obviously we have probably more experience than anybody in this country. Again, I don't mean to brag, but it's a fact. In terms of the procurement of this type of permits. There are several regulations. Again, one of the challenges we have is that this is an emerging technology. So this is actually being developed on the fly by the relevant authorities. There is a concern from the National Security Advisor's office of obviously the proliferation of this kind of technology crossing into the military space and unwanted monitoring of facilities. But there is a very thorough process that's undertaken by the Office of the National Security Advisor. There's a long process, but that is key. You have to be found responsible from a security perspective to be able to get or go further to get your permits. It's going to take a lot of time, and you must have a robust proof of concept. That is the only way that you'll be able to get that those permits.
Thank you. So just to inquire or get some more clarity on that response. So was this permit obtained by Oando, or it is outsourced to a contractor to obtain the permit and deploy the solution?
No, the end user essentially needs to be able to do the application. In our case, Oando applied for it because we saw the future and the need for such systems very quickly. And of course, you know, we typically would follow, be able to spot such trends very early in its infancy. So the company would apply for the permits, but as time goes on, you also have commercial operators who have licenses to provide services on behalf of people. Again, I mentioned a company called Proviant Integrated. They already they offer commercial solutions already, and they have relevant permits.
Thank you very much. That question from Reginald Bassi, thank you. All right. What can you say about the opportunities that abound in? Okay, we've taken that question, so I'll move to the next one. Please, what will be a preferred option? A, for organization to own and operate the UAV. B, to lease the service. Or C, to enter a service level agreement with service provider. I believe you have attended to this, but you can throw some more light.
Well, the best part would be to lease or to enter a service level agreement, because you have continuous improvement of technology, continuous improvement of sensor technology, as well as aircraft technology. So obviously you don't want to get stuck with one particular model when there's a new model that comes out probably every 6 months. So obviously if you lease, you'll be able to get the best benefit of the most current technology. Again, and the providers, some of the providers have access to these newer technologies and can upgrade, as needed. So that's probably the preferred option.
Thank you very much. So a follow-up question to that is if and how often they would need to upgrade the communication framework in rural areas.
So one of the things that is very, very important to determine how far your drones can fly is your communications network. Your communications network typically is not going to change in leaps and bounds, so you typically won't have too much communications upgrades to make, and you have definitely you have backward integration. So backward integration allows you to be able to use older communication systems to be able to run your newer systems.
Okay, thank you very much. So the next question says, from your experience and seeing that surveillance and security is a huge part of OPEX numbers in this part of the world, how do you assess the Nigerian oil and gas industry's response to these innovative technologies?
Well, like every single new quote unquote opportunity, it's slow, but it's progressing. Okay. You find out that a lot more operators are understanding that we have to keep up with the times. The traditional ways of doing things are not acceptable. We had started this journey in 2016. Wow. Yeah, it took quite a bit of time working with regulators, etc., etc. But we have to keep up with times. We have to innovate or die.
Fantastic. Okay, what height range does the UAV operate? And if significant, how do we avoid possible collusion with other military, commercial airlines, aeroplanes, and helicopters?
So very, very interesting question. So typically, the Civil Aviation Authority would grant you a permit with a particular altitude, which means that your operations can only exist in that particular altitude. Typically anywhere from 800 to 1,000 feet is typically where you would be operating in, which is just lower than your helicopter's operating area, which is typically 1,500 feet and above. And you also have innovative collision avoidance technologies in your vehicles, which obviously would enable other aircraft to be able to see that there's a vehicle in the area. You have return home features, collision avoidance, self-landing, and things of that nature. So these technologies exist. Again, I did mention the need for focusing a lot on safety, because you have a bit of a busy airspace above our installations.
Correct. I will merge two of the next questions. One says, how often do these drones require maintenance? And for a marginal field operator in Nigeria, how best can they reduce the operating costs of these drones to reduce the cost of production overall?
Okay, sorry, the first question again?
The first question is, how often do the drones require maintenance?
Okay, so you would have one of the advantages you have with the advances in technology. They are very small frames and they have interchangeable parts. So you can essentially swap them. And when you have a drone operation, typically you'd never have only one aircraft. Okay, so you'd have a series of aircraft, 2, 3 aircraft or 4 aircraft running a particular con-op. So as one aircraft is going up, another aircraft is down, being serviced, fueled, etc., etc. So there's a robust service schedule which has to be followed from a manufacturer's standpoint, which is obviously presented to the operator. And then, in fact, some of the parts can actually even be 3D printed. But obviously, your operator, your provider, must have sufficient parts and a maintenance schedule and redundancy. So you don't just have one drone, doing all the operations.
Mm-hmm. Okay. And the second question was, cost per barrel has increased very significantly due to security. So for a marginal field operator, what can they do to reduce the cost of managing these drones?
So it depends on, again, most of all these applications are tailor-made to the individual company. So again, as a small marginal field operator, what exactly is it that you're trying to do with the drones? If you have several facilities in different areas, then you might need a drone. If all your operations are concentrated in one area, you don't need a drone. If you have one pipeline to take a look at, then you might need a drone. Fewer drones, you can have fewer drones in terms of in this particular regard. You can have your flight hour cost being reduced. You can have less complex equipment. So you can have a smaller type of drone as opposed to, so for instance, if you're taking a glance at a pipeline which was 200 kilometers for argument's sake, vis-a-vis one that was 10 or 15 kilometers, you probably don't need the same type of animal.
Mm-hmm. Correct. So there needs to be an assessment done before purchasing the equipment.
Purchasing or engaging the provider.
Mm-hmm. Correct. Thank you very much, Engineer Anthony. The next question says, what are the biggest risks and concerns Owando has experienced with deploying these vehicles? What has been those setbacks, bottlenecks, and the roadblocks?
Well, essentially, one of the biggest bottlenecks were actually obtaining the relevant permits, and obviously being able to convince other people that indeed these are the technologies of the future. We've been on this journey for a while, like I explained. There's a serious human, what do you call it? A human resource skill that's needed. And putting that together, of course, you need to go with the right partners and the right providers. That is very, very, very important. But again, from a deployment of being able to convince people that the traditional way does not work, that's a major issue. And showing them the advantages has always been the major issue for us. And of course, very key, launch and recovery areas.
Okay, thank you. So just to add on that question, is Owando deploying these innovative technologies in security alone, or are there other aspects of your operations where you are deploying innovative solutions?
We are looking at several options for these equipment, both for surveillance as well as security, but mostly security. Security was the initial, was the major driver.
Okay, thank you. So the other question is, fiber optic cables for pipeline protection are easily damaged by vandals. How do we protect such damage?
So the first thing is to put fiber optic cables in existing infrastructure is very, very expensive, right? Because you know it's very expensive. Again, if you have a brand new infrastructure you're planning to build, then you can plan for fiber optic cables. Fiber optic cables are not really your only problem if you are looking for damage. The average vandal is not looking for your cables; he's looking for your pipe. So if he just damages the cable, then you're all right. But traditionally, it's going to damage the cable on the way to get into your pipe. So your surveillance technologies, like your drones, for instance, should be able to identify your vandal before he gets to start digging to your fiber optic cables and then digs to find your pipe. So you know that's what it is. Once they are damaged, they're almost useless, obviously.
And this would mean that your vehicles should run round the clock to be able to detect this kind of operation. Maybe
not. So your average bad activities and bad people normally work at night. So I mean, it's highly unlikely. You would have a pilot test where you do an assessment. The assessment will determine what kind of the patterns of life in that area, the people that come around the pipeline on often people would pass over a pipeline without malicious intent. But if you see a couple of guys in the middle of the night, with a couple of welding torches and some shovels, you know that they're not coming to plant trees in the middle of the night in the swamp, right? So yeah, those are the kind of guys you're looking for.
Thank you very much. I will take about 2 to 3 more questions and then we would wrap it up for the Q&A session. So the next question says, can there be a collaboration with all the IOCs and NOCs to have a central pool for surveillance requests? And this should go a long way to reduce OPEX for all the players offshore and onshore.
So one of the challenges we have is that Nigeria has is that each operator has a different set of problems. Okay, give you an example. In case ExxonMobil's business is offshore, they cannot relate to your problems in swamp. There are a couple of players on land that cannot relate to your problems offshore. So having one size fits all is a bit of a challenge. You may not be able to do a holistic one size fits all, but a central type of command where you would have a proper deployment talks to the future, which is one of the last few slides I talked about, where you have like an integrated global type picture. That would be coming. That's the future we ultimately see, but that's still a ways away.
Okay, and the next question is Owando a UAV security service provider? If yes, what differentiates Owando from Proviance?
We are an oil and gas E&P company. Owando is an oil and gas E&P company, and Owando is a player in the value chain of the oil and gas space. Proviance is a separate company. We do not own drones. We do not run drones. Proviance is a company specifically set up that has expertise in this particular area, plus the relevant permits and things of that nature. But Owando is essentially an oil and gas provider, oil and gas company. Proviance was born out of our own experiences.
Great, thank you. And the last question is, what are your biggest lessons you have learned in this journey? And has the cost benefits been felt in your cost profile for deploying this technology?
The biggest problems we faced, and one of the things we did not realize, was the complexity of getting this done. There is a serious complexity, especially if you're a pathfinder, like we were. We were the first people to obtain the permits in Nigeria. So obviously there is a bit of there are challenges when you're the first to do anything. Also, one of the biggest things we've realized is we need to plan. Very, very, very important. And we also have to have sensible and pragmatic and purposeful partners who are willing to give new technologies a chance and understand that the old ways of doing things would essentially kill us. And of course, taking a look at the regulations, like I said, are currently being done on the fly. And then, of course, you must have a robust stakeholder buy-in. If the stakeholders are not aligned to your vision, you are going to be climbing that wall for a while.
Great. Thank you very much, Engineer Anthony Sawyerr, for a very enlightening session this afternoon. With this, I will close the Q&A session as I invite Mr. Babafemi Onasanya, General Manager, Subsea, Owando Energy Resources, to give us the sponsor's remark for the next 5 minutes, and we wrap up this session. Thank you very much. Mr. Onasanya,
okay,
over to you, please.
Yeah, thank you. Good afternoon, everyone, distinguished ladies and gentlemen. First of all, I would like to say a big thank you to my colleague, Anthony Sawyerr, for a well-delivered presentation. Thank you. I'm honored to give the sponsor's remark of this SPE technical meeting. I represent Oando Energy Resources, a leading Nigerian independent oil and gas company, passionate about our people and in the forefront of the digital revolution. As you may know, Oando is a non-operating partner of the NAOC JV with a large footprint in the Niger Delta. Of course, this topic is dear to us, as you may know. Recurrent pipeline and well vandalization, especially in the Niger Delta, has had a negative impact on the operations of the NAO JV, which has resulted in a significant production downtime and revenue loss to us. Hence, today's topic of small unmanned aerial aquatic vehicle platforms for oil and gas asset surveillance, inspection, and security is very dear to Oando. And we believe with proper implementation can significantly reduce downtime due to pipeline and well vandalization. And I think Anthony Sawyerr did a good job telling us how we can, the benefit of using this technology. I would also like to use this opportunity to commend SPE legal section for hosting this e-technical session in line with the SPE mission of facilitating exchange of technical knowledge in the oil and gas and related technologies for public benefit and to provide opportunities for professionals to enhance their technical and professional competence. Oando is proud to be associated with the SPE and is committed to the ongoing collaboration with SPE to host and sponsor key events. In the last year or so, we have sponsored several SPE events, and our employees have been keynote speakers or panel discussants in several SPE events. Our Oando employees also recently published a technical paper that originally was to be presented at the 2020 NICE. Of course, that was converted to just publishing because of the coronavirus pandemic. As a company, we will continue to encourage our employees to be actively involved in the SPE and encourage them to serve as executives of the SPE legal section. In fact, Bumi Adeyinka and before her, Opeyemi Adetula held the executive position of the SPE legal section. As I close, I will also use this opportunity to encourage everyone listening to my voice to collaborate with us, the employees of Owando. We proudly call ourselves the humans of Owando, as we seek to end hunger and alleviate poverty in Nigeria, one community at a time, starting with Lagos. We seek to achieve this by what we call the aggregator platform, TAP, a unique initiative powered by the humans of Owando. As we are all aware, the coronavirus pandemic and lockdowns have made things extremely difficult for the less privileged in our society. Using a network of selected NGOs across Lagos State, the aim of TAP is to locate marginalized communities and help lift them out of hunger in the immediate and poverty eventually. I encourage you all to donate to this worthy initiative by visiting the website taptoreachall.org. A few posers for you. Do you know that even before the coronavirus pandemic, we had the under pandemic in Nigeria? 65% of Nigerians are food insecure, representing over 91 million people. And 41% of Nigerians live on less than $1 a day. And with as little as 6,000 naira, you can actually feed a family of 6 for a week. Hence, I encourage you to please donate, and together we can put smiles on some faces. Thank you.
Thank you very much, Mr. Onasanya, sir. We really appreciate your contribution to today's session. Before we wrap up, I invite Ms. Princess Ofor to give us a brief update on our SPE upcoming events, and we wrap up with the chairman's speech, Mr. Michael Sawyerr. Princess, over to you, please.
Thank you very much, Fayama. It's been a very insightful presentation thus far. So I'll just be running through what SP Lagos section has been up to in the month of October. So in the month of October, we have had a board meeting. Due to the situation of things, it had to be virtual. So we conducted a virtual board meeting and also had various technical events, 2 major ones being a webinar on leveraging business analytics in the oil and gas industry, conducted October 3rd. Another webinar on thriving with emotional resilience. This webinar, the recap to it can be found on our YouTube page. We also had young professional events, conducted 9 ambassador lecturer programs. We also conducted a pore to process flow modeling optimization pipe sim training course. And we organized an online quiz to celebrate Nigeria's 60th independence anniversary. For the student chapter events, we had a major one tagged the industry discourse by SP University of Lagos chapter, and that was themed the critical link, the now versus the future of the energy industry, which involved a whole lot of insightful presentations and seasoned speakers. So looking ahead, we have a student chapter focused program tagged the Spotlight. It will be holding October 31st. And it will be drawing leaders from various student chapters across the globe. And this is open to young professionals, students, and anyone looking to take up a leadership opportunity, because the panelists will be sharing their experiences from leading in various diverse environments. We also have an upcoming technical training, It is tagged Python for data science, predicting customer churn or attrition rates. So in this training, you'll be able to get insight as to businesses that require knowing how customer behavior changes, and this can be done using Python. So we have put up this information on our website and our social media pages, so more details can be found there. We have an upcoming webinar which will communicate the dates. It is tagged How to Boost Your Resilience and Leadership at Work. It will be taken by a renowned consultant, leader, and speaker, Javier Maria Angelo Capello. We also have a mini workshop themed Industry 4.0, which should be looked out for. It is tagged Technology Enablers for Realizing a Lower Unit Operating Cost. It will be holding in the last week in November 25th and 26th. It will also be featuring a virtual field trip. So please do well to register when the information goes out and be a part of it. Share this information with other professionals. Now, we would encourage you to stay connected with SP Lagos section. We can be found on LinkedIn, SP Lagos section 61. We can be found on Twitter, SP_Lagos. We can also be found on Instagram, Facebook, and YouTube. And like has been mentioned, most of our events, the recap can be found on our YouTube page. So do well to connect with us and stay connected so that you can get access to future events. Thank you very much, Fayama.
Thank you, Princess. Mr. Michael Oyere will now call the meeting to a close. Over to you, Michael.
Thank you very much, Fayama. Thank you very much, Princess, for the updates as well. I would like to really start by saying a very big thank you to our sponsors today, Owando Energy Resources, for taking us through a very important topic in our industry today. Really want to appreciate the speaker, Engineer Sawyerr, for doing a great job at enlightening us on this new technologies of which they have carried on board, championed, and I mean, the benefits are overwhelming. Thank you very much, Sawyerr, for that delectable lecture. Also would like to thank Mr. Onosanya, the General Manager, Subsurface Owando Energy Resources, for ably representing the Owando management today and giving us the sponsorship remark. I would also like to crave your indulgence to convey our gratitude to your management as well for this partnership. Let me also appreciate all our SP BOT senior members who are dialed in from all over the world or across the country today. I'd like to also appreciate our distinguished SPA members who have connected onto this meeting today. I'm hoping that it was of immense value to you, having shared your time with us. Just to mention that in order for SPE Lagos section to continue to serve us or serve you all better, we'll also be sharing a survey after today's event to try and get your feedback on how things can be done better. Would urge you to endeavor to participate in this survey and let's have your feelers. Once again, I'll just say thank you all for joining us today. Do continue to stay tuned with SP Lagos section activities. Enjoy the rest of your day and please endeavor to stay safe. Thank you all.
All right, thank you, Michael. Just to add, please, for those who have requested the slides for today's presentation, look out for the survey link so that we will use that opportunity to send you the slides. Have a great day ahead.
Thank you.